Starting now. Consider two bodies A, B having masses m1, m2 moving with initial velocities u1, u2 such that bracket में u1 greater than u2. Consider two bodies A and B having masses m1, m2 moving with initial velocity u1, u2 collides with each other. Let F be force imparted by A to B. Hence, B will give reaction minus F to A. Therefore, net force acting on system minus F plus F is 0. Let V1, V2 be the velocities of A, B after collision. Once you complete, then tell me.
Done, sir.
Shall I clear, Sarah?
Yes, sir.
For body A, what is initial momentum for
M1,
body
U1.
M1 U1, no?
M1 U1, yes, sir.
And final momentum?
M1 V1.
Correct. What will be change in momentum?
Delta P, which is M1.
Will be final momentum minus initial momentum.
Yes, sir.
What will be the rate of change of momentum? M1 V1 minus M1 U1 upon T.
Yes, sir.
Upon T. By Newton's second law, we know force minus F acting is change in momentum.
Yes, sir.
Force acting on A is minus F, that is rate of change of momentum. So minus F into T is M1 V1 minus M1 U1. I'm changing sign throughout. It will become Ft plus minus m1 v1 plus m1 u1 equation 1. Exactly same thing we'll write for body B. Initial momentum. What is initial momentum of body B?
M2 U2.
M2u2, correct. And final momentum?
M2V2.
M2v2, very true. And change in momentum?
M2V2 minus M2U2.
M2v2 minus M2u2. Rate of change of momentum?
M2U2 minus M2V2 minus M2U2.
That means divide by time, na?
Yes, sir.
M2v2 minus M2u2. M2u2 upon time. Please copy this much. Then I'm doing further.
Yes, sir.
Done.
Therefore, by Newton's second law of motion. Force acting on B is F, that is M2 V2 minus M2 U2 upon T. Therefore, we can say Ft will become M2 V2 minus M2 U2.
Yes, sir.
From 1 and 2 we get. Both left hand side of first and second are same.
Yes, sir.
Yes.
So that means first wala minus M1 V1 plus M1 U1 should be M2 V2 minus M2 U2.
Yes, sir.
So M1 U1 plus M2 U2 is M1 V1 plus M2 V2. M1 U1 plus M2 U2, is it initial momentum?
Yes, sir.
Initial momentum. And M1 V1 plus M2 V2 is final momentum.
Yes, sir.
Yes, sir.
That means we got initial momentum is final momentum when net force was 0. So I can say this proves law of conservation of linear momentum. Clear, no?
Yes, sir.
Complete this much.
Done, sir.
Okay. Collision. See, in physics, collision doesn't mean physically they should touch. Collision means even if one is attracting other, we say they are under collision. So when one body exerts force on another body, then they are said to be under collision. There are two types of collision. First, elastic collision. Elastic collision means, see, in any collision, momentum is conserved. Here, elastic collision is kinetic energy is also conserved. The collision in which momentum and kinetic energy both are conserved is called as elastic collision. Second, inelastic collision. The collision in which momentum is conserved but kinetic energy is not conserved. Please write, then I'm writing this point.
Yes, sir.
A collision in which momentum is conserved but kinetic energy is not conserved is called as inelastic collision. So that in case of elastic collision, relative velocity of approach is equals to relative velocity of separation. Relative velocity of approach equal to relative velocity of separation. Let's complete this much. Write this, then I'm starting. Completed?
Yes, sir.
Yes, sir.
Now, first, what is meaning of relative velocity? So if this is one body, this is another body, both are traveling in same direction. This is speed of 40, this is speed of 30. So I want to find what is relative speed of this B with respect to A. So first B should come to rest. ये रूल है ना, तो ये समझेगा ना ये कितना आगे जा रहा है.
Yes, sir.
तो हम लोग टू फाइंड रिलेटिव इसको रुकाने के लिए उल्टा डायरेक्शन में देना पड़ेगा सेम वैल्यू वाला स्पीड. इसको दिया तो इसको भी देख के देखो, तो ये रुक जाएगा ना जब ये 0 हो गया, तो है ना.
हाँ, sir.
तो ये जब 0 हो गया तो इसका नेट स्पीड क्या है? 40 माइनस 10, 10 से आगे जा रहा है ना ये.
Yes, sir.
नहीं समझा लगता है. इसको पहले मुझे रुकाना पड़ेगा ना, क्योंकि खाली मुझे इसका चेक करने का स्पीड इसका कंपैरिजन में कितना है. सी सपोज समबडी स्टैंडिंग ऑन अर्थ, अर्थ तो रेस्ट पे है ना, तो उसको जो भी सबका स्पीड है वही दिखता है ना, बराबर ना.
हाँ, sir.
हाँ, sir.
तो एक कार के अंदर ही आदमी बैठ गया है. नाउ व्हाट ही शुड डू, ये अपने आप को अर्थ जैसा करना चाहिए ना, मतलब एट रेस्ट. सो एज्यूम दैट सम velocity is applied opposite. Sum means same, 30, 30. So if I apply to one body, I should apply to other body. Then only it is mathematically true. So this will become 40 minus 30, 10. Na?
Yes,
So
sir.
that means I have drawn one conclusion. When two bodies are traveling with with different velocity in same direction, then relative velocity is difference. But A is moving on the right side and B is moving on the left. Now to stop this, I have to give the velocity in right direction. तो इसको भी right, तो इसको 70 लगेगा ना, ये वाले को, A को, इसका speed 70 है ना. Because when A moves ahead by 30, B is moving ahead by 40, तो उसको relative क्या लगेगा, ये 70 है ना.
Yes, sir.
So when in same direction, what is relative velocity? Difference.
Difference.
In opposite, what is relative velocity?
Sum.
So consider two bodies A and B having masses m1, m2 moving with initial velocity u1, u2 on a same straight path. So u1 अगर बढ़ा तो इसके साथ टकराएगा. So let the two bodies collide with each other after time t second and move with velocity v1 and v2 after collision. We have to check if it is elastic collision, then relative velocity of approach, which is u1 minus u2, must be same as v2 minus v1. Draw diagram.
Yes, sir.
Consider two bodies of mass m1, m2 moving with initial velocities u1, u2, u1 greater than u2 to collide with each other and move with velocities v1, v2 after collision. By law of conservation of momentum, initial momentum is equals to final momentum. So collect all m1 wala term together and m2 wala term together. So this is m1 u1 minus v1 equals to m2 v2 minus u2 equation 1. Since collision is elastic, hence kinetic energy is also conserved. Therefore, half m1 u1 square plus half m2 u2 square is equals to half m1 v1 square plus half m2 v2 square. Half, 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 half cancel. m1 u1 square minus m1 v1 square is m2 v2 square minus m2 v2 square. Copy. m1 u1 square minus v1 square is m2 v2 square minus u2 square. Copy this much.
Done, sir.
Did it?
Yes, sir.
Yes, sir.
Yes, sir.
Okay. So I can write m1 u1 minus p1 u1 plus v1 equals to m2 p2 minus u2 p2 plus u2 as equation 2. So dividing 2 by 1, we get m1 u1 minus v1 u1 plus v1 upon m1 u1 minus v1 is m2 v2 minus u2 v2 plus u2 upon m2 v2 minus u2. This will get cancelled. So we get u1 plus v1 equals to v2 plus u2. So u1 minus u2 is v2 minus v1. So difference in velocity, u1 greater is relative velocity, v2 greater relative velocity. So this is called relative velocity of approach, and this is equals to relative velocity of
Separation, yes.
So this proves in case of elastic collision, relative velocity of approach equal to relative velocity of separation. Right.
Yes, sir.
Yes. Then till last line.
Yes, sir.
Yes, sir.
Okay. To find final velocity v1 means in terms of m1 m2 u1 u2 formula for v1 will find. We know masses, we know initial velocity, we don't know v1 v2, so we have to find that in terms of that. What we got? Relative velocity of approach, same as separation.
Yes, sir.
I want v1, so v2 I should eliminate. So can I say v2 is u1 minus u2 plus v1?
Yes, sir.
Now we got in equation 1 m1 u1 minus v1 is m2 v2 minus u2. This we got by law of
Yes.
conservation.
Yes, sir.
Now in this I will put v2 ka value. So m1 u1 minus m1 v1 is m2, v2 is u1 minus u2 plus v1 minus u2. Therefore m1 u1 minus m1 v1 is m2 u1 minus 2u2 plus v1. So m1 u1 minus m1 v1 is m2 u1 minus twice m2 u2 plus m2 v1. Please copy this much. We are interested in v1, so v1 you have to collect on one side, rest all on the other side. Dividing throughout by m1 plus m2, we get v1 equals to u1 m1 minus m2 upon m1 plus m2 plus 2 times m2 u2 upon m1 plus m2. Completed till last line?
Yes, sir.
v1 equal to u1, that one completed?
Yes, I've completed
sir.
the box.
10 times you have tried to remember v1 equal to u1. देखो मुझे तो ऐसा याद हो गया, v1 equal to u1 हो गया, m1 minus m2 upon m1 plus m2 plus 2 times m2 u2, दूसरा टर्म आ गया upon m1 plus m2. Because in numericals we will not derive and waste our time. Directly we'll do.
Yes, sir.
So today stop here. Next class I will see explain you how to get v2. Then two condition: when mass one body is at rest, masses are equal, or one body at rest. And then we'll go to inelastic collision. Means coming week I will complete theory of this chapter.
Okay,
and
sir.
MCQ of circular motion also by taking extras. So by 19th, which is on Sunday,